Here at Bishop Museum, we hold the world's largest collections of biological specimens from the Pacific region, which stretches across a third of the entire planet. Bishop Museum has embraced the spirit of exploration since its founding in 1889. At the time, steamships represented the cutting edge of ocean exploration technology and revolutionized our ability to document biodiversity in the sea. As important as steamships were for ocean exploration in the late 19th and early 20th centuries, another even more important technology came along a few decades later that would revolutionize the exploration of coral reef environments. Dr. John E. Randall, known to his friends and colleagues as Jack, spent his career at Bishop Museum and was among the first marine biologists to use scuba back in 1946. Jack's two protégés, Richard Pyle and Brian Greene, worked alongside Jack at Bishop Museum for decades. They pioneered the use of advanced deep diving with special closed-circuit rebreathers to explore coral reefs at depths below where Jack Randall could safely reach using scuba. The legacy of exploration and discovery within undersea environments across the Pacific lives on at Bishop Museum as the Center for the Exploration of Coral Reef Ecosystems, or EXCORE. Our overarching mission at EXCORE is to use, and in some cases to invent, the latest available technology to explore and document biodiversity in ways that our predecessors could not. Submersibles, advanced closed-circuit rebreather systems, autonomous underwater robots, advanced long-term sensor arrays, underwater suction devices, environmental DNA sampling, stereovideogrammetry, and some of the most advanced underwater imaging systems in the world are among the specialized tools we use at EXCORE to discover and document coral reef biodiversity. Over many decades, the EXCORE team has traveled extensively across the world and used these technological tools to explore coral reefs. But exploration isn't just about going to strange places and doing exciting things. Exploration is about expanding human understanding of the world we live in. We have discovered and scientifically named more than 1,000 new species of fishes from coral reefs, only a fraction of which are shown here. On average, we discover 12 new species per hour of exploration time. As exciting as that sounds, fishes are just the tip of the undiscovered biodiversity iceberg on coral reefs. The real treasure trove of new species is among the marine invertebrates. For each new species of fish we've found, there are likely hundreds of undiscovered marine invertebrate species. These invertebrates aren't just beautiful to look at, they're also among the richest sources of new drugs. Some of the most important scientific research at EXCORE is the work of Cassie Ka'apu Lyons, who uses cutting-edge technology to fill gaps in our knowledge of fish larvae. Almost every species of marine organism has a tiny larval phase that drifts around as plankton in the open ocean. Because they are so small and occur far out at sea, the life history and biology of larval fishes is poorly understood. As a civilization, we spend 5 orders of magnitude more money on research into outer space and subatomic physics than we spend on discovering and documenting biodiversity. Indeed, these areas of research are vitally important to the future of humanity. So is global biodiversity. But there's an important difference. The universe and fundamental nature of matter and energy will be around for a very long time. Global biodiversity will not. We simply cannot afford to continue the status quo and battling the fire that engulfs the biodiversity library. The stakes are too high. A renewed focus on exploration, documentation, and discovery of biodiversity using the latest technologies represents our last best hope to save it. The future of humanity genuinely depends on it. There is no time to waste. Please immerse yourself in the undersea world of EXCORE and enjoy soaking in the art of underwater science.